Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue learning about pandas and timestamps. So in previous video we looked at what timestamp is and what are the general usage of timestamp in a time series, and looked at the format of how a timestamp looks like. In this video we'll look at the command pd.timestamp and see the general usage of that command, so that in future when we go in depth into time series, you'll know ahead of time what timestamp does. So pd.timestamp does. So let's get into Jupyter notebook and start coding. Here I've already imported two libraries, NumPy and Pandas, and from this video onwards I'm gonna add these versions, so Python, Pandas and NumPy version, so that we are all on the same page as to what version I'm working with. For some reason, if the command that I type here or code that I type here works differently on your computer, it could be a reason of that the versions are different. So the first item that I'd like to show here is how to use the help in Jupyter notebook when we are using this command. So pd.timestamp and with a capital T, and here if you type question mark, what this does is it opens the help menu that's down here, and in here it lists all the details that are needed to execute it. So pd.timestamp and all this information that goes into that command, and finally the description of all of that. So we'll use this in what we are going to type in this particular video. So first item that we can look at is what does timestamp actually do. And what it does is it converts a string in a date time format into pandas date time object. So it knows that it is time that is within that string after conversion. So let's create one variable x, and in that variable we'll store this value timestamp, and we are going to create a string to 2020 07, I'll say 10, and then I will give, so this is year, month, day, and then space, hour, and then minutes, seconds. So we'll stop here, so up to seconds. And now when we look at this, so this is a timestamp. So now when we access this particular variable x, and if we want to apply some time functions to it, we can do that because now it's a timestamp. There is another way we can create a timestamp, which is if we just have a date. So x is equal to pd.timestamp, and instead of hours and minutes and seconds, if we just have date, that also works. So we can type -07 -10. So this would also create a timestamp, as you see here, and the time part of that would be just zeros because we did not specify that information. Next, we could also use just an integer. So far we have been using a string. We can go ahead and use integers. Let me close this help menu down here. We can also use a string or integer. A pd.timestamp, and here if you specify 2, then what this does is it takes this integer as a nanosecond and it adds right here at the end of this timestamp string. So this is hours, minutes, seconds, and then this is milliseconds, this is microseconds, and then we are down to nanoseconds. And to check, we can always look at its value. So So x dot value returns us the nanosecond value of that particular timestamp. So if you remember from the past video, the starting point for the time is 1st of January 1970, and that's where this nanosecond was added to create this timestamp. Because we did not specify any other dates, that's what this is. Now here, if you increase the number of nanoseconds, what that will do is it will change the date as we go on. So if you add more zeros there, then as you can see, it now has the same date, but then the number of hours are different, and so on and so forth. So if you change that, now the dates have changed. So that's how we can use integer to create a timestamp. In addition to integer, we can also use floats. So x x is equal to pd dot timestamp, and now if we use 2.2 and look at x, again we have this timestamp which has now a value of 2 nanoseconds. The decimal part is not there, but if that is needed, there are other functionalities that can be used which can give you much finer time than what it is here. We can go below nanoseconds also. There are similar functions such as this in NumPy and base Python as well, as we saw in the previous video, but here we are not going to talk about those. Next, let's look at how we can use the unit. So we can go ahead and use the help menu timestamp, and what I'm going to do here is for units, these are the possible units that can be used, and I'm going to copy those and put them in here so that we can use them easily. Okay, so right now the timestamp that we are going to create is going to be based on each of these units. So far we used the integer or float without any units. Now we'll use the units and see what difference it makes to the timestamp that is created as output. So if we have 1, if we create it without any units, it's default taken as nanoseconds, and we can check that by specifying unit. So unit is equal to nanoseconds, which is ns, and you'll see that the output is the same as it was before. Now we can change this, so we can use a microsecond, and as you can see the 1 has shifted, and we can keep changing that. So we can use a millisecond, so now you can see it's in the millisecond range, and finally you can use the second, just 1s, and now it is in seconds, hours, minutes and seconds. Furthermore, we can keep going in this, and here we can use a minute. So as you can see, this is 1 minute now, and if we change this to hour, now you can see that this is 1 hour. And finally we can also use a capital D for day. So now as you can see, this has changed to 1 day. So there are different ways you can use the units to create a timestamp that you're interested in. And the use case would be you may come across a data set where you have these numbers such as this one, and this is actually time, which is the number of seconds or nanoseconds elapsed since January 1st of 1970. And to get a date from this, what you would have to do is use pd.timestamp. So this is one way, and if you know that those are nanoseconds, then you'll just put unit as nanoseconds, and then this is how you'll get the timestamp back out of that large number. Now let's look at other important points in timestamp, which is a time zone. So x is equal to pd.timestamp, and we'll again use 1 and unit. Let's put the unit as nanoseconds again. And for time zone, we need to specify tz is equal to, let's first use utc. Okay, and when we run this, this is, as we can see here, this is now UTC timestamp. As we saw in the previous video, this is like a reference which is the same all over the world. Now from this UTC we can compare the local timestamps in different time zones. So we'll look at one Asia Kolkata and another one is America Los Angeles. So if you type x is equal to let's put this as x underscore UTC, and the next one let's put this as x1 is equal to pd dot timestamp 1 unit is equal to, again we'll use the nanoseconds, and time zone this time we'll use the Asia and Kolkata. Next we'll use the time from a different time zone America, which is pd dot timestamp, again 1 unit is equal to nanoseconds, and time zone is America Los Angeles, Los underscore Angeles. Okay, and this we can now go ahead and print this. So print x underscore UTC, print x underscore 1, and print x underscore 2. So as you can see, the UTC timestamp, it does start at January 1st 1970, and then because we have one specified here as nanoseconds, we see that added at the very last, and the plus 5 hours or minus 8 hours, that is from UTC, and those are the local times, as you can see. So they are not exactly same, although the UTC time is the same for both of them. Next, moving on, let's look at how we can create timestamp by another method, which is by specifying year, month, day, and hour separately. So pd dot timestamp, and here if we specify the year is equal to 2020, month is equal to 7, day is equal to let's say 10, and hour is equal to let's say 23, and this timestamp will combine all this information to output a timestamp which looks like this, as you see here. Moving on, before we talk about another use case, I just want to mention that if you have a data frame where there are columns with year, month, day, and hour, then timestamp can be used to convert all those columns in the data frame into a timestamp as well. Now we can also use the same period or timestamp to create a timestamp if the data is separated out in columns in a data frame. For example, we have a data frame df, which is pd dot data frame, and in this there is a separate column for let's say year, and I'm going to create two values, just 2 rows, and then say we have the month, and along with the month we have the day and hour. So day, let's create 1, 2, and then we have the hour, which is let's say 12 and 14. So this is how our data frame looks like. Now if we want to add another column here which combines this information into a timestamp, we can do that. So df, we can go ahead and create another column df dot timestamp, df into square brackets timestamp is equal to df dot apply lambda x colon, and here we want to specify pd dot timestamp, and within this we are going to specify the values. So year is equal to x dot year. So this is the same convention as writing x open square bracket within quotes year. So either you can write that, or this is the shortcut way of writing x dot year. And then after that there is month. So month is equal to x dot month. Then we have day is equal to x dot day. Hour is equal to x dot hour, and we want to specify axis is equal to 1. So when we run this, what we get is a timestamp which is based off of these values in the adjacent columns of year, month, day and hour. So that's one usage of using pd.timestamp. Next, if we want to find the local time that's right now, so the time I'm recording this, so we can check that. So pd.timestamp.now, this will give us the time, current local time. So as you can see, the current local time is this 2300 hours 24 minutes on July 10th 2020. Now so far we have looked at how to create a timestamp. Now let's look at some of the attributes. So what attributes are is that they are additional information that we can get from out of the timestamp. So let's say we have again this timestamp pd.timestamp.now. We are going to use this timestamp, and let's see how the attributes work with this. The first one is day of week. So if we want to find x.dayofweek, then this gives us the day of week. So this is the 4th day of the week. Now today is a Friday, and I was expecting this could be 5, but it's 4. Let's change the date. So if we use the exact same string and create pd.timestamp and change this to 6, because I know that's a Monday. So when we run this and type .day of week, so it starts at 0, and therefore the day of the week, so Monday is day 0, and then so on and so forth up to Friday it becomes day 4. So the another we can attribute then we can look at is week. So week, so this is the 28th week in the year, and apart from week we have the week of the year as well, which should give the same value 28. And then we have day of year. So day of year, so this gives us, this is the 192 day of the year. A time zone we did not specify, so it's none, and therefore nothing is printed. Same thing with, we could also get the quarter, and this is the 3rd quarter. So these are really helpful easy attributes that we can use to get more information from a timestamp. And finally, along with this, we can also convert this to a NumPy timestamp format. So ASM8, so when we type that, this is the NumPy datetime 64 format that we can convert the timestamp into. Now apart from this, there are also methods that can be used along with timestamp. So methods, for methods we'll use the same timestamp x. If you type x.ctime and then open and close parenthesis, here we get timestamp back, which is formatted in a different way. So you have Friday, which is today, and then you have July, the month, then you have the date, and then the time after this. The year is the last item in that particular string. Apart from this, we can also go ahead and change existing values within a timestamp by using dot replace. So if you type x.replace, and let's say we want to change the year to 2025, change the month to maybe 12, and change the hour to, let's say, 23. Now if we look at the timestamp, we have changed it. So if we look at the original timestamp, we still have that, so it changes the copy of that existing timestamp, and we successfully changed the year, month, and also the hour. The day remains the same because we didn't specify a new value for the day right here. There is another function which is called timestamp. So x is the value for the timestamp. On top of this, if you type timestamp with a small t, open and close parenthesis, then what that gives us is the value in seconds. So the reason why this is seconds is because if we take this value and put it in our timestamp, so pd.timestamp, and as we saw earlier, we can convert floats. We saw that by specifying the unit. So if this is the unit is seconds, we can specify seconds, and we should get the same date as above, and exactly that's what we get. So July 10th, and the hours are the same. So if you specify a timestamp with small t open close parentheses, we get the seconds. And as we saw earlier, if you type value, what we get out is nanoseconds. So if we copy this and then put this again in place of the seconds, and then specify the unit as ns, then we get a similar value out as a timestamp. Finally, let's look at how we can convert this to datetime 64, and that is the numpy datetime 64. So x dot to underscore datetime 64 open close parenthesis, and this is the output that we get a differently formatted date time, that is a timestamp. That was it for this video. I hope in this video you learned about the general usage of pd.timestamp, and it's very important because when we dive deeper into the time domain in Pandas, if you already have an idea of how this works, then it will become much easier for you to look at the manipulations in the data with time. In next video, we'll continue this and we'll look at another command and look at how it can be used to work with time data. Please like, share, and click the bell icon below this video to subscribe. I hope to see you all in the next video. Thank you.